Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about the basics of C# with Godot. So we're going to talk about what C# is, why you want to use it, what makes it special. Then we're going to jump into how to install C#, how to install Visual Studio, what you need to know to make your stuff work. And then we're going to jump into the basics. We're going to go through what inheritance is, what type safety is, what lists are, what for each loops are, what classes are. We're going to go through a step-by-step instruction from the ground up to teach you about C#. And then in the next video right after this, I will be building a budget app to actually kind of solidify a lot of these concepts. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we should talk about is just why should you learn C#? And the first reason is C# is object-oriented. That basically means that you can model what the real world is like. So think about it kind of like if you have a person, you can actually set up a person object to define that person. So this allows you to have a big reusability mindset when it comes to C#. It's also extremely modular and has really great maintainability. The code itself is type safe. And what that means is it basically forces you to define everything before you start using it. A lot of other languages like Python or GDScript, you can kind of define things at will, and this can cause some issues with code reliability, right? So sometimes you'll be in Godot and you'll be running through something, and then suddenly you're like, why is this broken? And then you look at it and you go, oh, it's because I misspelled something or something like that. That's stuff that doesn't happen in C# because everything has to be defined beforehand. So the compiler will actually tell you what is wrong with your code a lot of times. So it's really useful. And the other great reason is it's a super versatile language. It supports all sorts of awesome features and it always evolves. I mean, Microsoft is evolving this thing all of the time. And that kind of drops into why we want to learn C# or why you should learn it. And that is, it's really versatile. You can create desktop apps, you can create web apps, you can create mobile apps, you can create video games using C# with Godot, and of course Unity. And you could do artificial intelligence. You could do so much with this language. It's actually kind of crazy. And the other big reason is it is a top language when it comes to jobs. And a lot of times people think about, I want to learn game dev, so therefore I'm going to learn GDScript, or I'm going to learn, I forgot what the language is, but it's for Game Maker. And those languages aren't bad. The job market's just really small for those languages. The nice thing about C# is if you don't make it in the game industry, or if you go outside of the bubble that is Godot or other game engines, knowing C# will get you a job somewhere. And it's always good, especially when the market's not very great, to know a language that is really strong and has lots of job opportunities. Another good reason is because it's extremely easy to learn. It's a little bit harder than other languages like Python or GDScript, but it's a super easy to learn language. And finally, it's got a huge community. You have so many resources and tutorials and things like that. It's just crazy how big the C# community is for software development, not for Godot. So that's something to keep in mind. The Godot community is extremely small right now. I'm one of the few so that's something else to keep in mind. So now the question is, okay, so you've heard C# and you've heard .NET, and .NET and C# are always kind of said in the same language, right? So what is .NET? Well, .NET is a free and open source platform that is supported by Microsoft. So it's owned by Microsoft, but it's open source, so you can actually go and contribute and download the code and use it for whatever you need. But it is maintained by Microsoft. And the question that a lot of people ask me is, why would you ever want to choose .NET as your framework? And the thing about .NET is it's a platform. It's not a language. I know that people think C# and .NET are the same thing, but C# is the language. .NET is the runtime that handles everything. It's the libraries, it's the frameworks, it's things like that. So the nice thing about it is it's cross-platform. And it allows you to build stuff for the web, for cloud, for mobile, for gaming, Internet of Things, AI, and desktop. Now, the first thing that we need to do is we need to actually download and install .NET. Now, I'm not going to go through the whole process of all the small, minute details here, but to use .NET, especially with Godot, you need to download .NET. So click on this right here. We're going to download .NET 8. .NET 8 is the latest version of .NET. So I'm going to download the unverified file. I'm going to double click on it. We'll go ahead and install it real quick. So I'll just click install, say yes to it going and allowing the installation. And then you'll see I'm going to need to close down the applications that are using my .NET version. So it's going to take a second, but it should go through. And now it's going to ask you to reboot your computer. So go ahead and reboot your computer and I will be right back. All right. And we're back. So once you have your reboot done, go ahead and at this point, we need to actually check to see if it's been installed correctly. So let's open up a command prompt here and let's bring it over here and type .NET --info. Now you're going to see here, it's going to give us lots of different information. So it'll tell us the different SDKs that we have installed, what version we're currently running, stuff like that. You'll see that it has our API runtimes and you'll see other architectures if there is any. Now you can see here, if you see right here, .NET SDK 8.0. something, right? In my case, it's 203, but in your case, it could be, I don't know, 209 or something, right? Depends on which one you pull down and at what time you're pulling this tutorial. But what you want to do is you want to make sure that you have the correct version of .NET installed. Now, once you know that you're running the correct version of the .NET SDK, if you scroll all the way to the top here, you can see version 8.0.203. That's the version that they're using. So that's just something to keep in mind. Now, once you know that, you have two options here. We need to have an IDE to be able to actually code our .NET code. And the best IDE for this is Visual Studio right here. This is Visual Studio. It is literally built from the ground up to be for .NET. That's what Microsoft has built it for. That's what it's for. Now, if you don't want to use Visual Studio, or if you are not on Windows, because this is a Windows-only application, that's where VS Code comes in. Now, I typically code in VS Code for Godot, not because I don't like Visual Studio, because I love Visual Studio. It's one of my favorite tools, but because you, the audience, are not always using a Windows machine. So I use VS Code. So be sure to install whichever one you want, and you can go from there. Now, in my case, I did Visual Studio Code. So if I type VS, you'll see here's Visual Studio Code, and it's probably going to open up all sorts of windows because I use VS Code for a lot of stuff. This is actually an A-star navigation system. That's a future tutorial that I've been working on. Now, if you use VS Code, it will not work by default with C# without installing the proper workloads. So you can see here on the left, you have your Explorer, but all the way here on the left, you have a little menu bar right here. You're going to want to click on extensions and type C# like this. And you'll want to pull down the C# dev kit, which is the Microsoft official C# experience, or you'll want to pull down the C# base language support. I'm pretty sure the extension has the dev kit as well, but you're going to want both. Both of them are extremely useful and both of them are awesome to use for your project. Now, one of the reasons why this is so nice is because it allows you to run and debug C# projects. If you go to your Explorer, you can see that there is a Solution Explorer here. And this is how we actually navigate our C# projects. You can see all the dependencies, the analyzers, frameworks, the packages, stuff like that. So it builds in a lot of that functionality from Visual Studio into VS Code. So some people say that VS Code might be a spiritual successor to Visual Studio eventually, though we'll find out when we find out. Now, once you have this, we are pretty much good to jump into coding our stuff inside of Godot and learning the basics of C#. So let's go ahead and jump into that. Now, for us to be able to code in C#, we need to basically go over the basics. So one of the biggest common basic task inside of C# that people do is called Hello World. And to do that, we need to create a script. So in Godot, if you've never used Godot before, all we need to do is come over here, click on user interface, right click on that control node and attach a script. We're going to call this app manager. And the reason why is because I don't want to create another script later and have to recreate another script. So we can basically just name it app manager and then we can use that going forward. So we'll click create and you'll see that VS Code has come up. Now, if you're still relatively new to Godot, you need to actually set it up so that VS Code will come up. So if you go to editor settings, and you scroll all the way down to the bottom over here on the left pane, click on editor, and then right here, change this from disabled to Visual Studio Code. And that will basically solve that problem. Then once you open up a script, it will show up right here inside of VS Code. So now we can close that. We don't really need that. And this can be closed. There we go. Let's clean all of that up. Now with C#, in order to basically print hello world out to the console, we can just do that in our ready. Now, I'll explain lifecycle and things like that later in the tutorial, but right specifically here, we'll just type gd.print. We'll hit quote hello world semicolon, and we will hit save. And I'll go through what all of this means in a little bit, but just know that this is basically how to do a hello world. So we'll click on Godot, we'll click on play, we'll save this scene, and then you'll see that it's going to pop up with another window here. And it will say hello world right here in the console. And that's basically the basics of C#. So now you know C# pretty much. Well, C# is actually a little bit more complicated than that, but you can see that we at least got it to do a thing. So that's exciting. Now, let's take a step back and let's talk a tiny bit about what this all means. And I'm not going to go through inheritance and all of that just yet, but I will say some of the basics, right? So I don't want to go through everything. We will cover that later in the tutorial. So first things first is the using. So using is a namespace, right? These are including namespaces into our classes here, or into this file, if that makes sense. And a namespace is basically a keyword that defines a collection of code, if that makes sense. So for instance, if you were to get rid of using Godot, you'll notice that suddenly C# does not know what GD is. It says the name GD doesn't exist in the current context. And that's the reason why using exists. It's saying, hey, I want to use the Godot library in this script or in this bit of code here. So you're basically just saying, I want to use this, and there we go, right? Now you might be asking, okay, why don't we just include everything, right? Why don't we just have using everything, right? Well, the reason why is because if we do using system.collections.generic and we create a dictionary, and I'm going to show you guys this, but don't worry, it's not a huge deal here. You don't have to follow along. So if I say dictionary D like that, you'll see using the generic type dictionary requires 2 arguments, right? Which is fine. So we'll go so you'll see we have a dictionary here. And then if I type dictionary like this, which dictionary am I using? So if you look at this, there's a dictionary here, which is Godot Collections Dictionary T value. And then there's a dictionary here, which is supposed to be System Collections Generic Dictionary. So that's where the namespaces kind of come in. That's where these usings come in, is you're telling the compiler, this is exactly what I'm looking for. And you don't necessarily have to use this if you don't want to. You can actually come in here and just type Godot.collections.dictionary. And that fully qualifies it, right? And it works. And then you can also do system.generic collections.generic.dictionary, and that also works. So now you'll see everything's happy. But this is an absolute pain to use if you have to do 50 dictionaries, or if you had to do a couple of strings or a couple of integers, or really anything that has to do with C sharp, you'd have to do these fully qualified connections. So instead, they came up with these usings to basically eliminate the need for that. So you can see if I get rid of system collections generic, like so, you'll see a system collection generic dictionary still works. You'll see that it's not unhappy with us. And if we get rid of this and we just have dictionary, you'll see that it works. And that's the purpose of a using statement. And that's the reason why we don't actually have everything included into your class. And also, the other big reason is because if everything's included into your classes, then if somebody named a class the same as something else, it could cause problems. So this is how they've worked around it, basically. Now here, this section here is a class, and a class is basically a basic concept of object-oriented programming, right? It revolves around making a real-world entity. So think of it kind of like this. When you create a class, it is a blueprint or a prototype of what that object actually is. And the nice thing about it is a class basically houses everything about that one object. So in this case, public partial class app manager is probably not the best title for example for this. But if I come down here and I say public class person, I can come in here and define what a person is. So I can say something like string name is equal to, let's say, empty. And then I could say int age is equal to 20, let's say, right? And then I can come in here and say public void get person's name, like so. And then I can return name, which actually this would not be a void. This would be a string. But you can see this is the definition of what a class is it's defining an object. In this case, it's a person. It could be a animal. It could be a gun. It could be a financial transaction, right? It could be a lot of things. But the idea is that you are encapsulating the data that is associated with that object, that person. So you can see in this case, I have a public class person. They have a name, they have an age, and I can get their name from them. So the idea behind C# is that everything is basically segmented into these reusable components, if that makes sense. Now I'm going to burn this and get rid of it, but that's basically the gist of it. And we'll talk about how to actually instantiate classes, how to actually use them, and stuff like that in a little bit. Now you'll see that a class is kind of broken up into three or four parts, right? So you have a public, which is what's called a access modifier. So you have public, private, and internal. And I'm going to completely ignore internal. Very rarely do I see people use it, but it is a thing. There's public, which means it's accessible outside of the class library. Private, which means it's not accessible outside of the class library. Generally speaking, you're not going to use this unless you're making class libraries. But if you want people to be able to use it outside of your project, right, outside of that specific project, you want to make it public. If not, make it private. It's always good to have proper access control. Partial, don't worry about this. This is a Godot thing and a generated code thing. So basically, because Godot has C++ in the back end, we have to have partial to kind of extend classes. Don't worry. Again, this is not something that you're going to see on your day-to-day life if you go and get a job as a C# programmer. Typically, you don't see this, but that is what that is for. Class, which is just telling us that it's a class. You have the name of your class right here, and then you have this little colon and then control. This is because of inheritance. So what this is doing is it's saying app manager inherits from control. So think of the world as like a big giant tree, if that makes sense. If you come in here and you have something like a node, and then you have something like control, and then you have something like app manager, right? So when you would do inheritance, what you're doing is you're basically saying that this node connects down to this control, which connects to this app manager. How inheritance works, and I will explain how it works on a more practical example later, but how inheritance works is if the node has a function called get name, right? Then if something inherits from that node, it automatically receives the function get name, like this. Okay. If the control node has something like get rect size, right? Then everything that it inherits gets that. But over here on a node 3D, node 3D doesn't get rect size because it's not inherited from the control node. But it does receive get name because it inherits from node, if that makes sense. So that's the purpose of this, is they receive every public method that this guy has, including variables. So if this guy had a variable, and I'll explain that in a little bit as well, but if it had something like public string name, right, then that propagates to all of these guys, like so. They all have that specific information. So it's a way to help encapsulate and organize your code so that people aren't having gigantic class files and things like that. A lot of times, like in C++, you'll have humongous files that associate with a bunch of different things. In C#, everything is very encapsulated. It's very reusable, if that makes sense. So that's basically the basics of inheritance. And that's what this is doing, is it's just saying that app manager inherits from control. If we were to get rid of that, it would get rid of these guys, right? It would say these guys are no longer there. But now this doesn't inherit from anything. So it loses that connection to the Godot code base, and it just kind of becomes its own class, if that makes sense. So that's basically what inheritance is all about. Now, what else are we looking at here? Well, this here is a function. And a function is a reusable piece of code. Now, think of it kind of like this. If I want my thing to do something, right, I can write my code right here, right? This area here is for stuff that's on startup. So like if I were to hit the play button, this section here runs first. Then this runs every single frame. So if I wanted to say hello world every single frame, I could do that, put that here, and then it will run every single frame of the gameplay. So if I come in here and I hit refresh, you'll see this is going to print out thousands of them really quickly because I have a pretty fast graphics card, so it's going to run pretty quickly. But you can see, there you go. Now, that's great, but when you're doing code, a lot of times, let's say you're building a really crazy AI pattern, right? We're going to detect the player, we're going to hunt the player down, we're going to go kill the player, stuff like that. This is perfect for what a process function's for, right? It's to run every single frame so it could do all these checks and do all these things. But having all of that code built into this one function is going to be horrible for maintenance. It's going to make things awful and really hard to use. So that's what functions are for. I can come in here and I can say private void print hello world like this, right? And then I can take this guy, I can control X, paste it in there, and then I can come in here and say print hello world like so. And now I've abstracted that code. You'll see that now our code still works, but it's now a single line here and a function right here. And you might be thinking, okay, so you just moved code, right? But think of it like this. I could have 50,000 lines of code in this one script. And I could have a function call here, do a little bit of logic, and then another function call, right? So I could have it all broken up so that they are segmented out pieces of code that are reusable. And that's the purpose of function. So functions are really cool, but what does all this mean? Well, much like classes, you have public, which is an access modifier. There's public, private, and internal. Once again, public is if you want it to be accessed outside of the class. Private for when you want it to not be accessed outside of the class. Then there's override. An override will override the parent level class's code. And what that means is basically everything that's in here will run instead of whatever's in the ready in the parent above it. And again, this is something that will come apparent later when we start talking more about inheritance, but just keep that in mind. Void means it returns nothing. And I know what you might be asking, because a lot of times people don't understand what this means. Void means it absolutely returns nothing. So nothing's going to happen, and it's not going to send anything back to anyone that calls that function. And then there's ready, which is the name of the function. And then there's these parentheses, which basically means it takes in nothing in this case. In this case over here, it takes in a double, which in this case is called delta. So what does this mean? Well, if I come in here and I type double delta like that, and then I pass in delta like that, it's going to take this parameter, it's going to pass it into here, and then it's going to pass it into here, and then it's going to send it here. So I could actually go hello world space plus delta dot to string like that. And then if I come in here and I hit play, you'll see that there's going to be an incrementing number that's associated with that object. You can see right here, it's showing that number, and you'll notice that the number is changing slightly, right? And the reason why is because what's happening is the Godot engine is sending this in to the engine, and then it's going to this print hello world. It's going to this thing right here, and then it's getting printed right here with the hello world, basically. So now that we talked about functions, let's talk about variables. So we kind of talked a little bit about that right here with our double delta, but basically a variable is a thing that houses data. And in a lot of programming languages like GD script, a variable's generic, so it can be technically anything. But in C#, everything is declared. And the reason why everything's declared is because it makes things a bit more efficient and a bit easier to work with. So since C# is strong type, that means that you have to declare what that data type is. So for instance, you can see here with double delta, that's me declaring it as a double. And so that's how we do strong typed languages. We have to tell it what it is. So in order to declare a variable, it's actually really easy. You just come in here, you type the type of variable. So string, which means a word, s is equal to this is a word, right? And then you also have int, which is a number, so 50. And then you have a float, which is a number with decimal, and that's 5.32 whatever, f, like that. And that's how you know if that is a float. Now, C# has a bunch of different types of variables that you can have. And variables don't have to be specifically those types, because there is just an absolute boatload of them. But variables can also be classes as well. And I know you're going, okay, hold on. We just talked about classes, right? They're like objects, right? Well, variables can also be classes. So if you remember our class earlier where I did a class person, right? And I had like a string s is equal to quote, right? Something like that. I can come in here and I can say person p is equal to a new person, right? Like that. And that's me basically creating a person out of thin air, right? That's me saying that that person now exists. So that's what variables are, is they're basically points in memory that we can change and adjust. Now, inside of C#, this is considered a scoped variable. And a scoped variable is this function gets done, this object, these variables get destroyed, right? So they're not going to be able to get used outside of this little function right here. And that's where returns come in. That's where all those additional things kind of come in. And what I mean by that is if I wanted to return a variable from this function, right? I can come in here and say return, and then I could return s, let's say the string, right? But you'll see we have an underline, and that's because there's a private void print hello world. Void means it's returning nothing. So C# is going, hold on a minute, you said this was returning nothing, so why is there a return statement? So that's C# kind of error correcting you, right? So we can come in here and say string like that. And then we can come up here and say var return string is equal to that. And then we can go gd.print return string like that. And now you'll see if I go into Godot real quick, and if we hit play, you'll see once it builds it, you'll see hello world, this is a word, right? You can see how it's printing that out. And that's because what it's doing is it's coming in here, it's getting this string, it's getting it set right here. It's coming through, it's creating this integer, it's creating this float, which are not being used. That's why it's grayed out. It's creating a new person. It's printing out hello world, and then it's returning S. Now that also works, by the way. You can set, like for instance, person's string right here. If this is a public string, you can actually set that. So if I hit p.s, you'll see that it doesn't show up, right? Even though there is a string. Let's change this to name, let's say, right? So if I go p.name, it doesn't work. But if I come in here and I go public string name, I can go p.name and it works. So that's basically that access modifier I was telling you about, right? So if I go p.name is equal to Frank, and then I return p, and I change my return type to person, I can come up here and change this to from printing return string to dot name. And you can see C# knows what everything is. And also one of the cool things is that you can actually change this from var to person. And now you know that this function returns a person right here. And you can see return string dot name. So if I save that, I can come in here, and actually I got an issue right here. So I'll put a semicolon right there. I can refresh this and you'll see that's going to fail because I missed my semicolon. So we'll control S, try that again. You'll see it's going to print out Frank every single frame. Also, interestingly enough, I could come in here and I could say, instead of p.name is equal to Frank, I could change it equal to S. Because it is a type string and this is a type string, we can make them equivalent to each other, and that works as well. So you can see if I hit play, you will see it says this is a test word, because what we did was we changed this to be equivalent to S, which is this bit of data here. So that's basically what variables are, and that's why they're really cool. Now, variables have different scope. Like I said earlier, everything inside of here gets deleted when it's completed. Like when this function gets done being ran, it gets called. Everything inside of it's dead. It's gone. So what we have to do is we have to return that data, right? So the person made it out of this entire thing, right? So number with decimal and string S are all gone once it gets out of this scope and it comes into here and it prints that person. This exists as an object, right? It exists as a thing because it made it outside of that scope. It got returned. So it came out of that scope, if that makes sense. But what if I wanted to save something for longer than that? Well, that's where class scoped variables come in. And if you come up to the top here, you can actually create a class scoped variable. So you could say person, let's say P is equal to a new person like this. Now, anytime this gets changed, it doesn't matter what scope you're in, it will always be right here. So I could actually come in here, get rid of this guy here. And now, because it's up here, it will exist at all times as long as that class exists. And this is stuff that will make sense later in the video, but just know that this is how you get stuff to stay between different things. Because remember, once process is complete, so once this function prints out the stuff, person gets called, it gets removed. So if you set a value and you want it to be alive for longer than the class function scope, then you need to add it up here and it will last over multiple runs of this class. Now, something to keep in mind is this also means that if the class gets called or gets nulled out, then it gets destroyed. So for instance, if you come in here and you say P is equal to null, then that's going to destroy that person. It's going to get rid of this object and it's going to basically remove it from memory. So that's how you can clean it up if you need to. Or if app manager gets destroyed, so if, for instance, you delete this node, then this entire class will get destroyed. So everything inside of it goes away, if that makes sense. Now, all of this is extremely confusing. It's a lot easier when you build an app to actually make it understand. Hey guys, Editor Mitch here. So I actually already recorded the entire budget app. I started going through the whole thing and it ended up being like 5.5 hours long. And I didn't even cover some of the stuff that makes C# good, if that makes sense. And, you know, I think I got like 2 hours in and I didn't even explain what an if statement is. So I figured that it might be good for me to split the budgeting app from the C# basics and basically release them out, you know, one day apart or a couple of days apart. So I'm going to go through some more basics here so that way you guys can see what else C# has to offer. Now, something you'll notice is that it says App Manager 2. And the reason why is because if you look here, I actually already have the entire budgeting app coded here because I already went through the whole tutorial. But like I said, I figured it would be better to give you guys a better foundation than what I gave you guys in the beginning. So with that being said, let's actually talk about some more foundational aspects of C# so I can better prepare you guys for the coming budgeting section of that tutorial. Now, the first thing I wanted to cover is if statements. If statements are really cool. Basically, inside of C#, we have the capability to do what's called an if statement. And an if statement allows you to say, if something is true, then do this. Now, in order to do that, we're going to need to get some user input. So in order to get user input inside of C#, we can do it one of two ways. We can go through Godot, which is what we're going to do, or we could do it through the console. Now, I'm going to do it through here because it makes more sense and it's a lot easier to work with. So what we'll do is we'll come here, we'll right click, add any child node. We're going to add in a button, okay? And a button inside of Godot is basically just a button, right? You can click it and do things like that. You come over here, we can add press me like this. And we can kind of pull this guy over here to the right. Now, if we come up here, we right click, add a child node and add in a line edit like that. We can just kind of put this like this and drag this over here like that. Now, in order to actually use this button here, it fires off this thing called a signal. And a signal is an event, if that makes sense. It's a thing. So a signal is basically saying, if this happens, do X, right? And you can have custom signals. You can have Godot built-in signals. You can have all sorts of different ways to interact with objects inside of Godot. And I will cover a lot of that in the budgeting portion as well. But I'm going to litigate a bit of it here as well. So over here on the right, there's a node section. And if you click on that, this is where all of the signals exist inside of your Godot project. You can see there's all sorts of signals here. There's button down, button up, pressed, toggled, focus, enter, exit, right? Things like that. Draw, hidden, right? All that kind of stuff. So what you could do is you could click on this guy, double click on your control node, copy this guy right here and click connect. And what that's going to do is it's going to tell Godot that whenever that button is pressed, I want you to run a function with the name that was below. So if we look at the signal, you have this receiver method. How it works is when that button is pressed, it's going to go to the control node. It's going to go into the script and it's going to say, where is underscore on underscore button down, right? Wherever it finds this, it will run that function. So if we head in here, we can say private void paste like that. And then anything in here will run. So if we type gd.print hello world like that, you'll see that if I hit play and I click on the button, well, unfortunately, I have that print statement running. So I'm going to comment that out, which that's another thing. If you hit // it comments that line out. That means that that line is no longer going to run. If you comment this guy out, that means that that line is no longer going to actually run. So if we come back here and I hit play, you'll see that nothing is being printed. And that's because these lines have been commented out, these two prints. So it will no longer print that information. And that's going to give us a perfect opportunity to click press me. You will see hello world. And that's because what happened was we clicked on this. It went to the tree. It found the control node. It went into the script and it said, where is this function? And then it ran this function. So how does that lend into an if statement? And how does that lend into actually getting user input? Well, inside of Godot, you have the ability to fetch nodes. So if you look at your tree over here on the left, you can see there's your control node. And here's where the script is located, right? It's located on this guy. You can run what's called a get node like that. And then you can type it by doing this little greater than symbol. And we're trying to get what the user has right here in this line edit, right? So we can do line edit, quote, line edit, because we need to tell it where we're looking, okay? And I'll show you guys what this means. So we're fetching this node back, okay? So we're fetching this object. So what we can do is we can say line edit is equal to that, right? And then we could print out our line edit dot text like that. And then if we head over here, we refresh this and I type hello world like that, and I hit press me, you will see that it's going to pull the information from here, send it into this guy here, and it's going to run this little guy right here, which is going to print it out. And that's basically how you can get user input. So how does that lend itself into an if statement? Now that's where it gets cool. So if we come in here, we can type if, and then we can use that if to basically run and segment our code. So what does that mean? Well, if we come up here, we can say string, we'll say choice is equal to line edit dot text like that. And then we'll go ahead and print out that text. And then we can do if choice is equal to quote 1, then gd.print line edit choice was 1 like that. And now if I come in here, you can see if I hit 1 and I hit press me, 1 choice was 1. If I do 2, let's say, and I hit press me, you will see it only prints out the 2. And the reason why it's printing up the 2 is because of this guy right here. But this little bit of code is not being ran. And the reason why is because the choice, right, that value, this little line edit text, so this guy right here, this text, is not equal to 1. Now you'll notice that I have 2 equals. And the reason why is because inside of C# and most programming languages, a single equal means that I am making this equivalent to this. I am equaling this to this. But 2 equals is a question. It's saying, is this equal to this? And that's a huge distinction. And inside of C#, you can also do not equal. So you'll see if I do that and I refresh, and then I set this to 2 and I hit that, you'll see that it runs choice was 1. Why? Because I put 2 in and 2 is not equal to 1. And that's basically what an if statement is. Now, if we change this back to equal, let's talk about an extension of the if system to the else system. We type else gd.print choice was not 1 like that. Now we can come in here, refresh this, hit 2, and you'll see choice was not 1. And you'll notice that what it did was we pulled back our line edit. We pulled back the text that they put in there. We printed it out. We checked if the choice was 1, which it wasn't, it was 2. And then we said, oh, well, if it's not 1, else, if this is not a true statement, then do this. So now you might be asking, okay, but what happens if I have multiple things? What if I want to check if it's a 1 and do something, or if it's a 2, do this, or if it's a 3, do this, right? Well, that's where else if comes in. So you can say choice is equal to 2. Choice was 2. And I could say that or 2. And now you'll see if I come in here, I refresh this. You can hit 1. Choice was 1. 2. Choice was 2. 3. Choice was not 1 or 2. And that's the beauty of the if, else statement. And this is basically the basis of building even the most complex programs. Every program pretty much uses a system like this to run. Now let's talk about arrays and lists. So arrays and lists are two of very similar things. So an array is called a collection of objects or a collection of data. And basically you can come in here and you could do something like int, and then you can, which is a type number, and then you could hit bracket, int array, and we're going to make that equal to a new int bracket. And inside of this little bracket here is the size of that array. So for instance, if it's 3 and I go bracket 1, 2, 3, like that. Now, if this is 5, then this should be 4, 5. Now, these values don't have to be sequential. You could have something like 2, 10, 30, right? So it doesn't really necessarily need to be an exact amount. But something that you'll notice is arrays are always the same size. So they're always going to be whatever the number is inside of here. And I can access that information by typing gd.print, and I can come in here and go int array, bracket, and I could choose a number. Now these numbers start from 0. So if you take a look, there's what's called an index, okay? And I'm going to come in here and show you. So if you hit 0, 1, 2, 3, 4, right? So that's how it works. So this is a 5 array element. So we have 0, which is our first index, 1, which is our second index, 2, which is our third index. And the reason why that is because back in the day of BCPL language, which is before like C language, so this was way back, probably in like the 70s, they determined that the pointer value of an address starts with p plus 0. So that's why 0 ended up being the first number, if that makes sense. So something just to keep in mind is arrays and lists and any type of collection just starts from 0. So if I were to type 0, that's equivalent to 1. If I do 3, that's equivalent to 30, right? Because it's inside of this array. So you'll see if I come in here and I go into this guy, I refresh, you'll see in a second when I run this, it will print out 30. See, 30 right there. And that's because this guy here is pulling this array value. And because we appended it, that means that I could do number 5 and it should just work, right? So if I hit refresh, you'll see it should just print 5. See, here we go. We got an error. See, this is another common issue you're going to run into. Index was outside of the bounds of the array. So what does that mean? That means that index 5 doesn't actually work. So what's up with that, right? We have an append right here. Well, that's because, unfortunately, I kind of lied to you, right? You can't really append to an array like that. And that's where lists come in. So if I come in here, I'm going to get rid of this little append here. And I'm going to come in here and I'm going to go list int. Int list is equal to a new list int, like that. So let's talk about what a list is. A list is a flexible array, effectively. It's an extended array that allows you to do a lot of really cool stuff. So if you want to add stuff to it, you can type int list dot add, like that. You could duplicate this and say add 5, 6, and 8. And then you could come in here and go int list bracket 0, like that. And you'll see that it's going to print that first element, the first one in that int list. So if I come into Godot here and I refresh, you'll see, hopefully, it's going to print out 1 like that. And the reason why it prints out 1 is because that's that first element in that array. If I set this to 2, you'll see that it's going to print out the third element in our array, which is going to be a 6. And you can see here, it is 6. So that's the power of lists. You can also remove stuff from lists. Int list dot remove, and then you can pass in the item that you want to remove. So in this case, let's say 6. And then if we print out, let's see, if I'm removing this one, this is 1, 0, 1, 2 is going to be 6. I'm removing 6, right? So this should print 8 now. There we go. It's printing 8 because lists are mutable. They can be changed, they can be adjusted, they can be altered, and that's the beauty of lists. Arrays, they have to maintain that size. They cannot be flexible in their size. And you'll also notice that the only thing you could do is change them. So if I type int array bracket bracket 2 is equal to 17 or 18 in this case, then that means that this array element here is going to become 18. And lists have the exact same thing. So if I go int list bracket bracket 2 is equal to 17 like that, you'll see that if I come in here and I refresh, you'll see that if I click this, it's going to say 17. And that's because this got changed to 17, if that makes sense. So that's the beauty of lists and arrays. They're basically collections of data that you can use, that can be used to iterate on. Now, the nice thing is arrays and lists can be of any type. So if I, for instance, want to come in here, I can get rid of this. I could do a list of person like this. And then I can create a new person. So I can say person P is equal to a new person, right? And this person's name is quote John, like that. And then I can add it to my list. So I can say int list dot add P, and that's going to add that person to that list. And I could do the same thing and add another person. Person is equal to a new person, like that. And I could say person dot name is equal to Madison, like that. And then I can come in here and go gd dot print int list bracket bracket 1, like that. And then I can come in here and I can hit go and click press me, and you'll see that we got an error. System out of range, index was out of range, must be non-negative or less than size of collection. So if we take a look, we did not add that second person. So we can go int list dot add person, like that. We need to add it to that list. And then we can go ahead and actually do it. So if we come in here, hit press me, you'll see it says person, which my guess is because I didn't do, yep. So you'll see it said person because C# only tells you the type of the object if it's an object. So what we did was we pulled that element out of the list and printed it. But if we want to access the name, we can hit dot name, like that. And then we can hit refresh. And there you go, Madison. And that's basically how lists and arrays more or less work. If we want to remove it from a list, we can say int list dot remove, and then we can remove an element. And we'll remove P because we have our person right here. So we'll just remove them. So you'll see that if I change this to 0, because that's what this guy is, he's index 0. If I remove John from the equation and it's just Madison, if I hit press me, you'll see it says Madison. Because the collection is mutable, it can be changed. So therefore, when we removed John, Madison moved up to the first person in that array and then that list, and then it printed her out, if that makes sense. So now what happens if we want to print both people's name? Well, if we come in here, we can copy this, right? And change this to 1 and then get rid of this remove. And that would print both these people's names, right? John Madison, right? But what happens if we have 500 elements in this array and we want to print all of them? That's when it gets hard, right? You don't want to duplicate this 500 times. Well, that's where for loops come in. So inside of C#, we have this thing called a for loop. So you can say for int I, comma, semicolon, I is less than int list dot count. So the size of that list, I plus plus. And we'll need to make sure that we do I is equal to 0 because we need to tell it what it is, like what value it's going to start at. And then we can say for this bracket bracket gd dot print int list bracket bracket I dot name, like that. And then we can get rid of these guys like that. And then we can come into C#, we can refresh this, and you'll see that if I hit play or I hit press me, it'll say John and Madison. And the reason why is because it's going and iterating through that list, and it's saying, let's grab the next element, let's fire it off. Let's grab the next element, let's fire it off. And that's what a for loop is for. And the nice thing is that you could start this at any index and you can iterate it based off of anything. So I could say I is less than 1, then do this, right? So now you'll see it's going to run once because it is going to be 0. And then when it hits 1, it'll be equal to 1. So it'll actually just run the one time, if that makes sense. Now, what if I want a little bit more of a friendly way to handle this, right? Instead of that weird way. Well, we could do what's called a for each loop. A for each is actually much simpler to use. You can say for each person P. Well, I guess I can't use P because I have this new person here. So we'll use per in int list bracket bracket. You'll see that how this works is what it does is it pulls this element out of this list, assigns it to this object here, and then allows us to use that. So gd.print per, like that. And you'll see if I refresh this, well, it's running person twice. And the reason why is because I didn't do per.name like that. So we'll do that. And we'll refresh this, and you'll see that it runs John and Madison. And that's the beauty of this system. So in order to create kind of like a really cool system, what if instead of doing this, right, we just had an array of strings and then we use that to create a list and then pass that list to this for each? Well, that's absolutely doable. So let's go ahead and get rid of this. String bracket bracket string array is equal to a new string bracket bracket, let's say 5 names. And then let's go bracket, quote, John, comma, quote, Madison, comma, quote, Mitch, comma, Victoria, comma, and then we get one more. So let's go with Alicia, like that. Then we can come in here and say for each var item in string array, person P is equal to new person bracket bracket semicolon P dot name is equal to item, because remember every element in this array will become this string array's item, right? And we could come, and so we're basically creating a new person. We're setting their name associated with that item, which I really should just go with name like that, just because it's going to be easier for you guys to read. And then we can come in here and say int list dot add P, like that. And then you'll see that after it's done, it's going to go through, loop through it, and print it. So you'll see refresh, press me, John, Madison, Mitch, Victoria, and Alicia. And that's the power of lists and for each loops and those kinds of things. It's a way for you to have a collection of things that you can iterate through and work with. Now, I think at this point, you guys have a pretty good understanding of C#. So I'm going to leave this tutorial here. And in the next one, we're going to go ahead and take all of this and build a budgeting app based off of these basic concepts. It's going to be a long tutorial, but it's going to be a lot of fun. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested, like all of my videos. So if you have any suggestions, please leave them in the comments below or on my GitHub. Link is in the description, and submit a ticket to me under Finepoint Suggestions. That's where I get all of my suggestions. That's where I find all the future tutorial ideas. And hey, if you have any questions or comments about this, please leave them in the comments below or jump on my Discord. Link is in the description. I'll be more than happy to help you out with any issues you might be having. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.